Hey everyone, and welcome. We have all been there, right? You're right in the middle of doing something, maybe something really important, and boom, the app you're using just crashes. Or it starts doing something totally bizarre. Well, today, we're going to pull back the curtain and take a deep dive into the secret life of these glitches, the software bug. It's one of those things that drives us all crazy, isn't it? You tap a button, you expect one thing to happen, and instead, the whole app just freezes up or disappears. So, what is actually going on behind that screen? That's the big question. And you know what? The answer is usually way more interesting than you'd think. You could almost say the software has a few uninvited guests lurking inside. We call them bugs. And they're kind of like the little gremlins of the digital world causing chaos. But what are they really? Let's get into it. Okay, so to really follow a bug's journey, we've got to be clear on what we're actually talking about. In the software world, there's a more official term for it, a defect. And this definition right here, it's perfect. It boils everything down. A bug, a defect, whatever you want to call it, is just a gap. A gap between what a program is supposed to do and what it actually does. Think about it. If you open a calculator app and type in 2 plus 2, you expect to see 4. If it spits out 5, well, that's a defect. It's that simple at its core. So where do these things even come from? It's super easy to just assume it's some developer making a typo in the code, but the real story is so much bigger and honestly a lot more human. Oh yeah, for sure. A simple coding error can do it. But bugs can also be born when a project's goals change halfway through, or from a simple misunderstanding between a designer and a programmer. Sometimes the bug isn't even in the app itself, but in another piece of software that your app depends on. It's a whole interconnected ecosystem, and one little disturbance can create a huge ripple effect. And just like they come from all over the place, bugs themselves come in all shapes and sizes. They're not all these dramatic system-crashing monsters. Some are way more subtle, messing with everything from how an app looks to how safe your personal information is. So first up, you've got the ones you can see, the UI/UX defects. This is when a button is just in a really weird spot, or an error message pops up that makes absolutely no sense. The app might still work, technically, but the experience is broken. It just leaves you feeling frustrated. Then there are the performance defects. You know these. You've used an app that makes your phone get super hot, or completely drains your battery in like an hour. Or my personal favorite, the one that just shows you that spinning loading wheel forever. That's a performance bug, and it's like an invisible thief, stealing your device's power and your patience. Now we're getting into the really scary stuff, security defects. These aren't just little annoyances, these are actual backdoors that could expose your private data, your passwords, your credit card numbers. These are the kinds of bugs that make headlines when there's a massive data breach. Finding these isn't just a priority, it is an absolute must. And believe it or not, even the instruction manual can have bugs. A documentation defect is when you go to the help section and it gives you the wrong instructions or leaves out a super important step. It's like getting the manual for a chair when you bought a table. You're just not going to have a good time. All right, so you found a bug out in the wild. What's next? Well, you can't just run to a developer and say, hey, it's broken. To actually get it fixed, you have to put on your detective hat and write a really solid bug report. This quote absolutely nails it. A good bug report is basically a recipe. It's a super precise step-by-step guide that lets a developer create the exact same problem on their own computer. Because here's the bottom line. If they can't make it happen again, they can't fix it. It's as simple as that. And this table here, it's like the anatomy of that perfect recipe. You need a clear summary, like a headline. You need the exact steps. You need to explain what actually happened versus what should have happened. And this part is so important, attachments. A screenshot or a quick video is the ultimate proof. It can save a developer hours of just guessing. Okay, so once a bug is reported, it gets reviewed. And that process involves two super important ideas that people mix up all the time: severity and priority. So severity asks, how badly does this bug break things? It's all about impact. But priority asks, how quickly do we need to fix this? That's all about urgency and business needs. Let's break down those severity levels. At the very top, you've got a blocker. That is a total showstopper. It means nobody can do any work. Critical means a core feature is just completely broken, like you can't log in or you can't check out. High and medium cover all sorts of major to minor problems. And then low is for the small stuff, maybe a typo somewhere that doesn't really hurt anything. So that leads to a really interesting question. Can something be super severe but still be a low priority to fix? And the answer is absolutely, yes. Imagine a bug that makes the entire app crash. That's high severity, for sure. But what if it only happens on a 10-year-old phone that like 0.01% of people are still using? The business might look at that and say, you know what, it's a low priority for us to fix right now. Okay, so the report is in. Severity and priority have been decided. Now our little bug begins its official journey through the system. And this is what's called the bug life cycle. So it starts out as open. As soon as a developer grabs it, it moves to in progress. When they think they've got it fixed, it becomes resolved and gets passed over to the testing team. And if that team confirms the fix actually works, the bug is finally closed. Bug squashed, mission complete. And you gotta know, this is not just some casual back and forth. Teams use these really powerful tracking systems where every single report is logged, assigned, and monitored from start to finish. It's a highly organized hunt. And it has to be, because the sooner you catch a bug, the exponentially cheaper it is to fix. Seriously, a bug found after an app is released can cost 100 times more to fix than one that was found way back in the design phase. But here's where the story gets a twist. Not every bug gets fixed. Sometimes a report is a duplicate. Someone else already found it. Sometimes the team just cannot reproduce it. It's like a ghost in the machine that disappeared. Then there's my favorite, by design, which is a very polite way of saying, that's not a bug, it's a feature. And sometimes a bug is just labeled won't fix because the time and money it would take to fix it just isn't worth it. And just when you think it's all over, a bug can come back from the dead. If the testing team finds out that a so-called resolved bug isn't really fixed at all, they change its status to reopened. And then the whole life cycle, the entire hunt, starts all over again. So you might be wondering why all this process, all these rules, these reports, these life cycles. Well, it's because this incredibly detailed, meticulous process, it's the invisible engine that makes our digital world work. Without it, things would fall apart. And sometimes the consequences can be truly terrifying. And that leaves us with one last, really critical thought. What's the real cost of a bug that slips through the cracks? Well, back in the 80s, bugs in the Therac 25 radiation machine led to patients receiving massive overdoses, with horrific results. In 2012, a single software bug at Knight Capital cost the company $440 million in just 45 minutes. The stakes can be unbelievably high. So the next time your app just works, maybe take a second to appreciate the army of digital detectives working behind the scenes hunting for those ghosts in the machine.